Hi, this is Kento Kamiyama Physical Therapy. Welcome to our channel.
Now, without further ado, I'm going to do a quick introduction of Mike Zhao, or Michael Zhao, whatever his official name is. He's a movement specialist in New York City, a personal trainer. His email web address is effortlesskinetics.com. I don't know how I was kind of thinking about this last night and 2 nights before. I have no idea how to introduce him. I have no idea, but I do want to talk about him, like how we met a little bit. I think we met like 3 or 3.5 years ago, probably, through a mutual friend. And as we were talking, I was like, this guy's smart. This guy is very, very smart. And we just got to be talking together a little bit more. We got to know each other a little bit more. And what I did notice about Mike is that I believe he has a gift. He has ability to read very complex books, textbooks. He'll recommend me books that are like 2,000 pages. And I said, Mike, I have 2 kids. I have no idea how to read 2,000-page books. But he is able to, that aside, he is able to read these books, take courses that are very complex, understand it, and explain it to other people while still having the big picture and able to go into very specific if he wanted to. And not only can he do that, he can also integrate other theories and complex theories together in order to make sense. And it's not because he's making sense in a sense that it's like, oh yeah, like, I don't know, right equals left type of thing. It's not that. He thinks about it from a scientific standpoint, good reasoning. And, to me, he often blows my mind. So to be honest, I'm so excited that he's here. Mike, thank you so much. I'll have you introduce yourself in a second. And it's a treat for me today. So we're going to do Q&A. Hopefully we don't go down the deep end too much too soon. We are going to time ourselves. We have 3 topics that we want to cover today. We're going to time ourselves so we cover everything. But these are topics that can be talked about for 3 hours or 4 hours if you wanted to. But Mike, let me just have you introduce yourself. Let me just unshare here, if you don't mind.
Yeah. Hey guys, my name's Mike. So let me dive into a little bit of my background on how I got here. So I served in the Marine Corps from 2007 to 2011. After I got out, I took the following couple of years to get my degree in sports science and kinesiology. Once that's out of the way, I spent majority of my continuing education studying various topics within biomechanics, neuroscience, cognitive psychology, and contemporary psychoanalysis, with the intention of building and refining a interdisciplinary model for human learning. And what I do day to day is applying that model and the research into movement training with my clients. Right, so that's a relatively sort of casting a wide net of what I do and who I am. I'm definitely one of those people that is married to my work. It defines me. I define it. So one could say that I don't very much have a life beyond that, but this is definitely my life. But yeah, and here we are.
Excellent. So just to remind everyone, today's title is about optimization of movement training and integration of contemporary mechanics and behavioral sciences. So this is going to be a good one. I'm going to be doing more of the Q&A. So I'm going to be asking questions that Mike and we were kind of going through together and going through these things. So we have some couple agendas. Just to give you guys an idea, we're going to kind of talk about how to balance between old movement patterns or old memories with new memories. The second one's going to be about biotentegrity, a little bit about fascia. And the third one's going to be, I think, like deadlifts, how we're thinking deadlifts right now and how strengthening or strength training can improve breathing patterns. So these are very heavy topics. We will be asking questions. I will be asking questions. If you have any questions, feel free to put it in the chat. Our goal is to be going through each topic like 15 minutes each. If you guys like the topic, we might just expand it and we'll just kind of put it into different parts. Mike said, okay, that if we do it into different parts or another time next time. But feel free to put questions as we go. So, Mike, you ready?
Yeah, let's do it.
All right, so let's get into it. So we're going to talk about the first one is about balancing old movement objects or memories with new ones, and the couple of things we talk about is familiar, chaos, and creativity. So I'm going to relate it to physical therapy or trainers if possible. If someone comes in to like look for my services, for me, often someone comes in for like some kind of injury. So either they have low back issues, headaches, neck issues, etc. So as a typical physical therapy thing, you do your assessments, and I give them some form of probably new exercise that's something they were missing. So I have to give them a new movement pattern that they have not achieved before. So when it comes to that, when it comes to giving someone new movement patterns, what are some deep or main questions that you ask yourself in order to help that process?
Okay. So the first thing when I'm in that position, I want to figure out how easy would it be for me to build a bridge, for me and the client, for the two of us to build a bridge between what the person needs and what the person currently can do. Meaning, if we simply go in thinking that, oh, okay, this person doesn't know how to do this, but he or she needs to do this, and that's all we focus on, a lot of times you're gonna get blindsided with tendencies from the learner that defends against foreign things, foreign experiences, right? Really good example. If this person deadlifts constantly with erectors, like lower back muscles, like for everybody who's not in our industry, there are these muscles on either side of your spine, of your back, that we can use for things related to getting up off the floor and picking things up off the floor. That's an option. However, a lot of times once you do that, they tend to have something to say about it. These muscles tend not to be happy about being used. So if that's the case, a lot of times we want to shift the responsibility to other more appropriate muscles. Well, that all sounds nice and everything if your client is a robot. If your client is a car or a robot, that's really simple. You rip out the stuff that you don't want, you put in the things you do want, you restart the thing, and you're good, right? But unfortunately, human beings, or fortunately, human beings don't work like that. And you need to have some kind of a transition. You need to facilitate some kind of a transition from whatever it is that they're familiar with, familiar but undesirable, but nevertheless familiar, into what is foreign and desirable, right? Because to the brain, that good, bad patterns are completely arbitrary. It doesn't know what is good. It doesn't know what is bad. Otherwise, the healing professions would not even have to exist, right? If the brain has a good, enduring set of rules for what is good, what is bad, nobody would need help because nobody would get out of line. But anyways, right? These bad patterns, these dysfunctional patterns, these inefficient patterns, once they habitualize and they become familiar, you need some kind of a bridge, right? So my job in the beginning is figure out where are they at and how can I begin to pull them out of that by something that is, let's say, they are operating at 100% of the bad pattern and 0% of the good pattern. My job is not to give them something that is 0% of the bad pattern and 100% of the good pattern. They're going to simply reject that. Their brain's going to reject that. Their conscious mind may want that very much because everybody wants to do things more effectively, more comfortable. In your case, Kento, out of pain, right? But that's not realistic. Instead, how I'm thinking, how can I give them a pattern that is 90% bad, 10% good? Okay, cool. Check. What that's good. Their brain, their motor system, their sensory system can accept that, and their emotional systems can accept that. Cool. Move on. 80% bad, 20% good, and so on, so on, so on, and gradually to 0% bad, 100% good, right? And for everybody, for every individual, this framework is going to look completely differently, right? And another thing about appeasing the old and introducing the new is that there is no such thing as algorithms. There's no such, or rather, I don't believe in algorithms. There is framework, and how that individual's experience is going to give meaning to how the framework is being carried out. Right, and I know this sounds kind of vague, and I see like faces that are like kind of connecting dots, and some faces that are not connecting dots. So, for example, if a person who has been using their lower back to get themselves out of a chair, or walk, or deadlift, or workout for a long time, and somehow they are not in pain, but their muscles, their lower back muscles are tight all the time, and they're just constantly used. Well, if you tell them to simply turn abs on, they may not even sense abs, right? They may not even sense abs. You can even palpate them, like put your hands on their abs, and it's like rock solid. And then you ask them, yeah, do you feel abs? They're like, yeah, a little bit, a little bit, right? That's a sign that whatever it is you're doing is too unfamiliar to them, is too good. Right? It's too good. It's too effective in taking the person out of that dysfunctional pattern. You need to put some dysfunction in there, or you need to give them a easier way into this new pattern that is super foreign to them. Right? So in that situation, I would want to figure out just kind of like a series of guesses, like literally educated guesses. It's not an infinite number of guesses, but in my head, I will have like 3 options of like what is probably going to work, right? I'd run them through it, and I pay close attention to which of the 3 gives them the kind of experience that will be conducive for the next step. Meaning, how can I get this person to feel abs accurately? Meaning, cool, their abs are turned on with 90% intensity, and I check that with my own palpation. I put my hands on them and see how hard their abs are working, and check in with them to see how much of their abs they experience, right? Because if your abs are not on, well, you shouldn't do anything. But if they're working, I want to make sure they're sensing what's going on accurately. Yeah, authenticity is a big word, but like accuracy in sensation is the first thing that gets lost when the new is too unfamiliar, right? So I want to see how can this person sense his or her body accurately without compromising my path. But yeah.
Okay. So let's break it down a little bit more. Let's go back a little bit, if you don't mind. So you kind of talked about how to utilize the individual's movement patterns, or what they have in memory, in order to move forward. Mm-hmm. So I think that's an important part, because a lot of times, at least in my profession too, and I don't think it's any different when it comes to the physical therapy, the fitness industry too, is we get kind of bogged down on what's right or wrong. Yeah. And it's not necessarily that, but you kind of talk about how important the process is. Do you have any ideas, or maybe break it down to kind of possible memory science that you have, or why the reasoning with what you're going through?
Yeah, absolutely. So yeah, this definitely has to do with how memory works. And when I say memory, I don't mean the colloquial sense of using memory, meaning like childhood memory, or what you remember of like what you did last week. It's not that. From a cognitive psychology perspective, memory is simply the word for how the brain processes information, manages information, and organizes information. Meaning, what we all are doing right now is a memory task. What we're all doing right now is a memory task. So when we're learning things, the reason why we cannot simply learn new things without a foundation, so there are 2 dimensions of the answer. So I'll go with respect to how meaning is formed first. So as example, if you're looking at, if you're trying to understand, chairs come to mind for some reason. So if you are in a furniture store, right? If you're feeling adventurous, like a really contemporary furniture store, and the designs are really out of this world, and there's like all kinds of weird shapes, and you ask a store attendee, what is it that I'm looking at? And they're like, a chair, and you're like, well, I've never seen a chair like this. But you sort of stay with it, and you keep looking at it, you keep trying to learn from it, and your brain's idea of what the hell a chair is begin to mend with this weird thing that you're looking at, right? But the weirder it is, the harder it will be for you to understand that it is a chair, because all the crucial pieces that defines a chair in your mind have yet to be found in this new weird shaped object that you're looking for. So the mind pieces definitions together based on how they relate to you. So a chair is something you sit in, and there's a degrees of comfort with respect to the chair. And now, how many legs does it have? Does it move around on wheels? Is it hard? Is it not hard? Right. So all these things are unconsciously being processed by your brain whenever you look at a chair. Right. So if you see a chair and the part where there is a seat is empty, and the legs are uneven, it's harder for you to see that as a chair, as an example, right? And this phenomenon applies to every piece of information we try to learn, right? There needs to be a bridge between the foreign thing that you're trying to learn and what you already know, right? And if the pendulum is swung too far the other way, you have the reverse issue, meaning you can't learn what you already know, right? If it's exactly the same as something you already know, it's going to be hard to even pay attention to the thing. It's going to be hard to even pay attention to the thing. Cool, Kento, you're back. Yay. But anyways, yeah, so that's why with movement, it's very, very similar. So the lower back thing versus, either abdominals or hamstrings or something else you're going to use to address this misuse of lower back muscles. Well, you at the most surface level, these two approaches are completely opposite, right? Completely opposite. One is on one end of the body, the other is on sometimes the opposite side of the body or completely different floor of a building, meaning lower back versus hamstrings. So you need to have a common ground. You need to have something that they're in common with, right? So maybe focusing on the task itself would be the common ground, right? Both of these classes of muscles, classes as in dysfunctional, functional, with respect to the case you're working on, well, the thing that they have in common is that they both classes of the muscles serve to help you pick something up or serve to stabilize the spine. Although the spine stabilization piece may be a longer term objective, right? Maybe later down the road you can introduce that to your clients, because at first nobody knows what that means. If they did, they wouldn't be here, right? But at first, just the fact that they both can be involved in picking something up may just be the common ground that they need, right? So now you have a diagonal reference point with respect to two opposing things that allows you to reference all three, Like, this isn't necessarily how you would consciously run this thing, but this is how it works. You can almost kind of think of it like immunity, meaning how do you get healthy after you get sick? You don't know, right? You don't know. You're just gonna rest. You're gonna take whatever medication you need to take. You drink a lot of water. But none of those things are, directly related to how you get healthy. Your immune system doesn't exactly work like that. Nor do you know how your immune system works. So you just know that if I do X, Y, and Z and I don't mess it up, I'm gonna get healthy again. So how your memory works with respect to learning and how learning is managed is just as unconscious as how your immune system fights off viruses and bacteria. Right? But yeah, Kento. So
sorry about that, guys. My brain's okay, but my computer freaking
makes sense.
Just blew up. So I apologize for that.
Yeah, we'll get that sometimes.
So I'm assuming you just explained about like the memory aspect of things just now.
Yeah.
Guys, and if you have any questions within it too, because sometimes it's good to know where how you guys are taking in some of the information. And if you have questions in between, I can go back as well. Because Mike and I talk on a fairly regular basis, so we don't know where we are at sometimes. So just please feel free to ask questions as we go. So Mike, I don't know. So we talked about memory and how it works a little bit more, the chaos aspect of it.
Yeah.
Any more add-ons on that? Because time-wise, we can go into the biotensegrity part of the fascia.
Yeah, no, let's do that. I think there will be little tie-ins back to this, but for now, I think biotensegrity will be a good thing to sort of like move on to.
Oh, great. So I'm assuming. So explain to us a little bit about biotensegrity, then. Then let's go from there.
Okay, cool. So a little bit of history. For a long time in the biomechanics field, kinesiology, which is the sort of field of science that personal training, strength coaching, strength training, physical therapy all falls under. All these fields are, I almost look at them as applied fields of kinesiology. Kinesiology is the overall research academic science that underlies all this stuff. But anyways, for a long time, kinesiology has been under the influence or has been based upon Newtonian physics, levers, hinges, and things like that. That all sounds great and everything if you're building a building. That all sounds great and everything if you're building a seesaw or something, simple like that, where it's hard pieces of material with other hard pieces of material. Most of y'all have probably noticed the human body isn't any of those things. There's nothing particularly hard about our bodies. Even our bones deform all the time, constantly. So a handful of very smart people that have strong physics backgrounds realize that they need a model update. They need a model update away from levers that does not reflect the mechanical behavior of pieces of the body. And that really got kicked off when folks began to look at what fascia really is. And for all of us who's been to a cadaver lab, fascia is kind of like this saran wrap looking thing that covers your muscles and it's like right underneath the skin and the fat, right? And for hundreds of years, anatomists have been looking at it as exactly that. It's saran wrap. It's not the stuff I want to see. So as soon as I get a cadaver, guess what? Well, guess what I'm going to do? I'm going to get rid of all of that and get to the stuff I really want to see. And it wasn't until the mid 90s people started realizing, okay, there's like stuff here. There's important things here. And so as an example, the fascial tissue in your lower back is some of the strongest things around. So in I think 2007, for those of y'all, let us know if you want this paper. So in 2007, a bunch of folks did a study to test the tensile strength of the thoracolumbar fascia, the fascia in your lower back. So the machine that they used was rated at 1 kilonewton, which translates to about 22,000 pounds of force. So this machine can put out that much force. And the result of the study was that the thoracolumbar fascia was rated at 1 kilonewton, meaning its tensile strength is at 1 kilonewton. But it gets me thinking, because they specifically say that the machine is rated at that. And they didn't. The thing is, they didn't rip the thoracolumbar fascia when the machines turn on full power. So we actually don't know if the thoracolumbar fascia is more resilient than that. That's just the strongest machine they had throwing at it, right? So if a stronger machine were to be applied, we actually don't know if it will survive as well. We just know that it is at least 22,000 pounds of force. My point is, as far as you, the individual, is concerned, your thoracolumbar fascia is indestructible to you. You will never produce force anywhere near damaging this thing if it's healthy. Right? So,
Mike, sorry, I don't mean to stop you for a second. Yeah. Just to kind of go back a little bit. For those that are unaware, can you guys hear me? Man, my computer's going off like crazy today. Yeah, okay, great. More reason for me to buy a new computer. Anyway, so I saw you, Mark. You're thinking. Okay, so A little bit for those that are unaware or haven't heard about fascia, like, Mike talk about like a saran wrap around the body. If you ever seen like an orange too, it's like the orange, like the white part of the orange. But also for some of the research is that if you ever seen any fascial research, like the IT band or fascia, like the normal fascia itself, and Mike, please check in, kind of comment anytime. Normal fascia itself, just the fascia, they say it's anywhere in the fascia, it could be, to even change it at 1%, they talk about 2,000 pounds of force. And the thoracolumbar fascia, I believe why Mike is talking about it is there's layers. There's multiple layers in thoracolumbar fascia. What that means, it's like, think about rubber bands just getting stacked over each other. That also means that multiplies in the strength of like that literally passive elasticity aspect of it gets really strong. So it becomes what, Mike, you said, like it's 22,000 pounds it could hold, and it didn't break then, so it probably can hold even more.
Yeah.
So to not utilize that from an evolutionary standpoint, I believe, or we believe, it just doesn't make sense.
It doesn't make sense, and it actually goes against how this whole thing has been designed and has been evolved. The other parts of this movement system as in fascia, muscles, and bone, the other components of this movement system was never designed to take on this kind of force at a repetitive in a repetitive manner, right? So I started this thing, this topic right here with the thoracolumbar fascia because that is your gateway into the rest of the fascial system. It'll be much harder to integrate a holistic use or systemic use of fascial loading without the thoracolumbar fascia. Right. So think of it this way: fascia is interwoven into every single muscle. Right, for your fellow nerds, between each sarcomere, you have fascia. So it is all the way down to sarcomere level, and then epimysium level, endomysium level, and what's the one that's the whole muscle? I don't remember. Anyways, so it is at every level of muscular organization, right? And it is connected across every single bone. It is even within your cranium, and all these different regions across your whole body is one continuous network. When people study this, they simply, theoretically dissect it into pieces just so they can name it, right? Something. It's like how United States, bunch of states, but it's all continuous, right? So my point is, once you begin to load one piece of it, it is immediately going to distribute all of its forces and perturbations across the entire network. It's kind of like a trampoline. Think of a trampoline, right? If you're laying on one side of it and you drop a heavy object onto the opposite side of the trampoline, you're gonna feel it here, even though the drop was here, right? Because the trampoline itself is trying to distribute the forces here across the whole network, right, of tension. And your fascial network works exactly the same way. So what does that look like in movement, right? Kento, also you need a new computer quick. Anyways, actually, next time you get kicked off because your computer is lazy, just go order a new computer right then and there, and then come back. But anyways, all right. So what does that look like in movement, right? So if your fascial network is engaged, and you need to walk somewhere, Well, so if your left leg is the first one you start swinging, right? All right, cool. So you swing your left leg forward, and then on the back end, the back of your left leg, all the fascial tissue there is on stretch, is loaded, right? So you can think of a rubber band, a multi-layer, expensive-ass rubber band being stretched and loaded, right? And then when you need to when that step is done and you need to propel your body forward and swing the right leg, all that elastic energy stored in the left leg is then transferred onto the right leg because it's the same network, right? It's not like bones where they don't technically touch at joints. That's a different topic. They don't technically touch. Fascia, it's all touching everywhere, right? It's directly touching everywhere. So if we can utilize this, it allows us to compensate for whatever misgivings and disadvantages of any given area by other regions that are designed for the task. For example, loading. Certain parts of your body is not meant for compressive forces, right? Spines don't handle compressive forces very well. When I say spine, I mean like the spinal column, the bones themselves. They don't handle compressive forces very well, right? So if they're left to their own devices, you're not going to last very long. You're certainly not going to hunt anything. Your species is not going to last very long. Your hip, however, they handle compressive forces really well, right? The top of the hip joint, the hip socket, is reinforced time and time again every time the primate subspecies evolve into a new form. Like that region, that top region of the hip socket gets reinforced, right? So same goes for the top of your femur, your femoral head, so to speak, the ball. That also gets reinforced. So they deal with compressive forces really well. So then the job is to take the forces that would be going to the spine and somehow funneling it into a more stable object, i.e. the hip. And you cannot do that without fascia. Or rather, you cannot do that without active involvement of your fascia. Yeah, Ken, does that flow?
Excuse me. I think it flows for sure, but definitely I need a new computer as well.
Yes.
Yeah, it's the first time that's done it. I wanted to say information overload from a certain someone, but just I'm not going to name anyone.
Yeah,
So anyway, so that was awesome. So I'm going to actually answer a question that we are getting about fascia. So any thoughts on like when these tissue deform to the point of failure? Any thoughts on that? If there is a good question, if that's a question to be answered for that one. From that point, like where it's almost, from what we know, at least the thoracolumbar fascia, like going to 22,000 sounds is like close to impossible. Unless you go into like an accident or something like that.
Exactly. It's something you cannot do yourself. However, the fascia, so that happens in a healthy individual. Right, that happens in a healthy individual. And there are a number of ways fascia can be placed in a state that is less than efficient. So stress is probably, like psychological stress, is probably the biggest contributor or regulator of fascial state. And this comes in, this is there established for a very interesting reason. So within your fascia, there are mechanisms that lays down more material to make it thicker and stiffer. And then there are mechanisms, opposing regulatory mechanisms, that makes the material thinner and more elastic. And the former, the thickening mechanism, is very sensitive to cortisol. So the more cortisol you have in your system, the thicker your fascia is going to be. And the less elastic it's going to be. It's then going to behave a lot more like steel, right? It's going to be more brittle. It's still hard and resilient, but when it deforms, it's going to break, rather than an elastic deform like a rubber band. At which point, the more you deform it, the more efficient your whole system is going to be, because it's going to store energy that you can be reused in or repurposed, right? But if it's stiff, then you're going to have a harder time going through ranges of motion. But if you force yourself to do it for whatever reason, emergency or something like that, things are going to crack, right? And they don't have the best blood supply, because they're collagen fibers, right? They don't have the best blood supply, so then it's going to take time to heal and things like that. But it's largely temporary, right? It's not like, well, even bones heal, but like it's not like bones, once you snap it, you're gonna like set it, and it will always be imperfectly set. But fascia the way these things are laid across layers, there are connections between layers. So it's not like one layer and then one layer and they have nothing to do with each other. There's actually fibers between layers, and each layer is, that's a lie. So each layer is made up of multiple layers. Each layer is made up of multiple layers. So their striations are always not unified. So like when scar tissues get laid down in muscle fibers, or particularly muscle fiber or skin, they generally don't get laid according to the striations of the tissue, right? So if your muscles run like this and they break, the scar tissue is gonna get then built in this like almost like a random pattern manner, and that messes with your range of motion function and things like that. That phenomenon will still happen in fascia, but it matters less because it was made to go in omnidirectional anyways. It's not a directional tissue. But yeah, so it is possible to break it, but it requires psychological conditions. It requires certain psychological conditions for it to break.
Yeah, that was fascinating actually. So like how cortisol just connects to how the thickening aspect or the thickening mechanism of the fascia.
Right.
I'm sure all of us has experience where you were just tight one day when you woke up, and you just no matter what you did, like no matter stretching you did, massage, maybe there's a psychological component to it, but that leads to just like feeling just overall tight.
Exactly. Yeah, absolutely. And if you have a particularly bad fight with your significant other, certain things are going to get tight, and doesn't matter what you do, it's going to stay that way. Like it might get better for like 5 seconds, it's going to come right back until you deal with the actual issue, whatever it is. Then it magically gets better. Except it ain't magic, it's just physiology. But yeah, that's like another massive topic. We can talk about that one day. Definitely.
No, that's perfect. That's perfect. So then let's go into the next one, because I think that would be a great way to segue through it.
Absolutely.
Is the deadlift aspect of things. Yeah. So I'm assuming you're going to connect the thoracolumbar fascia connection into the new deadlift. So if you don't mind, just kind of expand on that.
Yeah, absolutely. And I think it's going to connect to the first topic really, really well as well. The transitioning from old to new. So for deadlifting. For as long as deadlifting has been formalized into a sport, into an exercise, whatever, spine extension has been the key. Because of that, it has caused a lot of problems in a lot of people. It has caused a lot of freaking problems. Because it sounds really good on paper, and again, it's a remnant of Newtonian thinking, right? They want to make the spine into a pillar. They want to make the spine into a pillar, and how you would deal with oblique and diagonal forces in a pillar system is by redirecting it into a convergence opposing point, right? So if you're deadlifting and you can make your spine into a rod, then you want to drive that rod into your pelvis, into your legs, and then forces get dissipated. Again, that sounds really nice on paper. Reality does not work that way. So largely because if your spinal erectors, meaning spinal extensors, the muscles in your back that does this to your spine, if this is your face, this is the back of you, and does that, they cause a very stereotyped set of issues. One, the backs of your spine. I'm an idiot. So the backs of your spine, where all this stuff gets attached, they're gonna essentially get pulled down like that. And forces are going to press into here, right? Because these muscles all lay on the back of you. There's nothing to even them out. There's nothing to even them out. So rather than having forces evenly distributed across this whole ring, only the back of it is going to take on these forces. That just doesn't sound like a good idea, does it? You don't even need to know any mechanics, engineering, or architecture or anything like that. It just doesn't sound like a good idea, right? So you wouldn't build buildings like that. Yet we have been teaching deadlift that way for decades. right, for decades. That's how it's always been taught, right? So in a biotensegrity model, we sort of respect the other resources, the superior resources available to us, i.e. your fascia. So your thoracolumbar fascia is in some ways a continuation of your obliques, your oblique muscles. Your obliques they don't connect to thoracolumbar fascia, they become the thoracolumbar fascia. And then the thoracolumbar fascia fuses into the sides of your spine and the back of your spine. So for my fellow nerds out there, spinous process and transverse process, they are the two fusion points between the spine and the thoracolumbar fascia. In other words, the thoracolumbar fascia can be thought of as a common tendon of the oblique group and lats and glutes, hamstrings, and a bunch of other stuff. Okay, and they are that common attachment point onto the spine, and it is sort of like mapped out kind of like this on either side. So when they get pulled down by the obliques, you now have an evenly distributed force onto the spine, because we all know obliques bends the spine forward, right? So you have this force that bends the spine forward, but at the same time, its back posterior attachments also pulls the spine up. So now it is evenly distributed. One. Second of all, it is done through this massive network that is ready to distribute forces everywhere else, literally everywhere else. And it answers a very pressing question, which is, why does using back muscles to control your spine so damn ineffective? And what are we going to do about it? Well, so if your spine is chronically like this, well, guess what? Your thoracolumbar fascia never loads. So the most powerful thing by very, very far on your body is just never used for this task you do all the damn time. No matter who you are, you're going to be bending over and standing back up, bending over, standing back up throughout your day, right? And this most powerful thing doesn't get used. Therefore, you are out of practice. Your motor system, your brain doesn't know how to use it, right? So when you do need to use it for emergencies, for daily tasks, you won't know how. It's not even that like you're doing the wrong thing, you just won't know how. It's like learning a foreign language that you never knew existed. You're not going to do that. You're not going to use that, right? So this way of deadlifting actually encourages the user to allow the spine to flex itself, like bend itself over completely, loading the thoracolumbar fascia, right? Because a lot of us traditionalists, okay, I don't know about me, but traditionalists may be thinking that, well, isn't that how I hurt my spine? And no, so your lumbar, your fascia will never let that happen, because it's the strongest thing there. What is there to overpower, your fascia? Are you ever gonna lift anything, more than a couple hundred pounds, right? Like you're gonna be well within the tolerance range of this invincible tissue, right? So the interesting thing about that is you're not going to sense your fascia, because they do not have big, thick sensors like your muscles, your tendons, your joints, and things like that. So when you load that thing, it's a very eerie sensation, especially for people who have deadlifted for a long time and have even developed a strong deadlift. It's a very eerie sensation, because you're standing there with the weight, conceivably a significant weight, but you don't know what's being loaded, and it's strange, right? And you feel your abs on, and it's so counterintuitive, because your abs, traditionally would not be involved here, right? Because if you're bent over, your abs should be involved in pulling you down further. So what the hell is it doing, trying to turning on while I'm doing that, right? It's a very counterintuitive thing, and this bleeds into the old new thing really, really well. A lot of people struggle with using this even after they've understood it, and they do it, and they're like, wow, my lower back feels awesome doing this. but it is so weird. I don't like it. I don't this and that, this and that, this and that, right? Because it's so against the habit they have formed. It's not good and bad. It's familiar, unfamiliar. So anyways, yeah. So this way of deadlifting, when you do it, you should feel a lot of obliques work because they're literally pulling up your spine. They're literally pulling up your spine in the most counterintuitive way, right? You can think of guy wires or like rubber bands hooking up to a tree. I don't know if y'all have seen that, like city sidewalks, like the square plot of dirt, and then there's like 4 wooden sticks alongside the tree, and there's like rubber bands hooked up to the tree, right? And it has equal tension on any direction. So the tree, if you watch it throughout the months, it's going to straighten in the same principles as fascial networks. Because if the tree is leaned this way, well then the rubber band here is going to be loaded a lot more than here, right? So then it's going to start pulling this more. By the time it's equal, well then all 4 rubber bands will have equal amount of pressure. Now the forces have been evenly distributed everywhere. So with the deadlift, it's the same thing. When you're bent over and you got your fascia on, well then your thoracolumbar fascia, coincidentally the strongest part, is taking on most of the force, right? And as you stand up, it takes on less of the force, and when you're all the way up, all fascial regions around you are holding on to the same amount of force. We're good. All right. So yeah, that's kind of like that's the new I guess our new way of deadlifting. And Kent, we've been using this for like a year now. Like no, about a year, right? Yeah, roughly about a year.
Give or take a year.
Give or take a year, and the results have been very consistent and somewhat unbelievable. Like I've studied the science of it a little bit, and it's still kind of hard to believe considering like what traditional thought processes would tell us to do. But you can't argue with the results. So I want to talk about two case studies related to this real quick. One has a lot more to do with the first topic, and then the second has a lot more to do with the second topic. So one of mine and Kento's mutual clients, this gentleman has had lower back issues for a very, very long time, had a surgery for disc herniation, and largely these days, or the reason why he started working with us is that, well, he's kind of recovering from the surgery, if that makes sense. He's kind of recovering from the surgery, and picture this, right? So to get to the herniated disc, to get to the discs, the surgeon has to get through to the bone, to the actual bones of the spine. That meant he had to cut through the skin, cut through the fat, cut through the fascia, cut through the muscles. So the fascia is damaged. All right, fascia is damaged in a way that it's not accustomed to being damaged. But you may be thinking, well, you just said like this 202,000 pounds, how is it going to break? Well, you're pulling on it and cutting is different things. But yeah, so anyways. So we have this issue, and it's probably stitched together, right, after the surgery is done. So now the stitching is in the way of the fascia's natural mending process. So this gentleman has profound difficulty feeling obliques because the obliques are a part of the thoracolumbar fascia, right? The brain knows to not let that region load itself. So he is stuck with using erectors, like lower back muscles. And as the time goes on, we begin to slowly heal this and slowly encourage through exercises, through specific design exercises for his fascia to heal and stretch and load itself more and more. He begins to sense his obliques more and more. And once that happened, the most unbelievable thing was that his personality noticeably and significantly brightened up. Now, at first, he just sounds depressed. At first, very irritated, depressed, don't want to deal with new things, just don't want to deal with things at all. But once this turned on, and at this point, he doesn't know what it means. It just, Kento and I got really excited because he can sense abs now. And he doesn't still know what it means. I'm not sure he knows what it means now. I'm glad he's not here, looking at this. But anyways, yet his personality almost did a 180 turn. Okay, 160 turn, not completely full, right? A significant turn. And that was like Kento, like 2 years ago? 2 years ago at this point, right, roughly. And now his personality only continues to brighten up and refine and become more open as his thoracolumbar fascia gets more efficient in its loading, right? So fascial networks has a lot to do with how receptive to new things we are. Now, I want to be real clear about this. I'm not suggesting that opening up your fascia is going to make you a more open-minded person. Our gentleman here also has 2 therapists that he works with, one psychiatrist that prescribes medication, and one talk therapist that works with his mind directly, as well as whatever me and Kento had learned on in terms of coaching, in terms of psychotherapy, as it is applied within our scope of practice in coaching. Also is a driver for these things. The mind controls the body, not the other way around. Right? Anyways, yeah, I noticed this is a dangerous, dare I say, trend that our industry has been going towards. I definitely don't want to be a part of that. Anyways, so yeah, Kento, do you want to say something?
Oh, sorry. Like I was just looking for pictures because there's a lot of concepts in here, and for those that are like new, I mean, I hope you guys get to see the replay a little bit. Hopefully my computer didn't go so haywire, but anyway, I'm gonna share a picture of the obliques a little bit from a cross section. I don't know if this is gonna help, Mike. So for those that are unaware of like the thoracolumbar fascia, I think this is a good picture.
Yeah, that's a great picture. Yeah, that's a great picture. Absolutely.
So if you guys take a look at here, and Mike just correct me. I mean, anytime if you that I'm incorrect on these things.
Yeah.
If you guys look at here, you can see the blue little excuse me here. So if you kind of see here, there's this like nice little light blue things that are kind of surrounding the multifidus, the rector spinae muscles. So that's part of the thoracolumbar fascia in the context that we're talking about.
Mm-hmm.
So we got layers, right? In this picture, they talk about 3 specific like big layers. There's more to it if you're going to break it down even more. But look at how the oblique muscles, so the front here, so we're going to talk about here, these muscles here, these are the internal obliques and transverse abdominis. And if you take a look and if you go all the way back to here, see how it connects to the thoracolumbar fascia and how the thoracolumbar fascia interwarps into the spine, to the vertebrae.
Yeah, so this picture, the big black arrows kind of get in the way of exactly what we're trying to point out. So you see the most inner ring of obliques, where the tip of the black arrow meets, right? There's a tiny little blue segment, right. That's actually where the fascia becomes the muscle, and muscle become fascia. So there's 2 layers of the thoracolumbar fascia that comes from the transverse abdominis and internal obliques. Right, meaning internal obliques and transverse abs actually become 2 converging layers of the thoracolumbar fascia.
Beautiful, beautiful. So I hope this helps paint a picture for you guys, like the reasoning why when Mike is talking about like this different deadlift and how the oblique starts to matter on how to utilize the thoracolumbar fascia. This is just one view of it. But just seeing how it could relate. I hope I wasn't intruding, Mike, but I think
no,
at least it was the connection for individuals that are seeing, right, where like when we're looking at deadlift, we're looking at like using the rector spinae, which is not necessarily wrong. What I believe Mike is saying is by utilizing everything, the complexity of what's going on in the most efficient way, we use the rector spinae in order to help us through the thoracolumbar fascia.
Yeah, because I want to encourage this tool type thinking. The body is a tool for you, right? The body is a tool for you, is a part of you, but is also a tool. Meaning, you need to select the right tools for the job, right? If you're going to lift heavy, your erector spinae is going to be a big limiter. They're not strong. They're not strong, right? You have 5 segments of your lumbar spine and a lot more if you go up the building. And your erector group per level, per vertebrae, they're not very big, right? They're not very big because they don't extend out very wide. Your abs, however, your obliques, however, for each level, you have all that tissue surrounding you. So you have way more force per capita per level for this, right? So if you want to go heavy, you are not going to do that without obliques and without thoracolumbar fascia. It's different tools for the job. For a lot of other things, your erector spinae is going to be just fine, right? But is this tool that you're selecting appropriate for the job you want to do?
Yeah, that's awesome. I hope we're kind of, at least from what I know, we're coming full circle a little bit more. If it was kind of like this to some of you, and that's what I would have experienced when I first met him. Now I'm just like, it's just like normal things now. It's still crazy, but it's. I hope you guys are getting something out of it. So I think kind of we came back full circle. So we're gonna go into some of the questions I received. Is that's okay, Mike?
Yeah.
And if we do have a little bit of time, I have a little bit of time. So like we are, I don't know if you're open to like open-ended questions.
Yeah,
or
for sure.
my questions.
Yeah, absolutely.
So I have one here. So I'm going to read it out loud here. When do you know a new movement pattern is stable enough to add velocity or maximal loading to the movement without the client resorting to an old compensatory pattern?
That's an excellent question. So you do and you don't. What I mean by that is you kind of, like the first time you challenge that, the first time you test that, it's going to be a guess. It's just not going to be a blind guess. It's going to be an educated guess, right? You know some of the parameters because you've been with this person long enough to build this thing, right? So you have some idea of like what he or she's capable of, what he or she is going to be aware of, right? So you want to then throw in some parameter changes at it, right? So we're talking about deadlift, so let's just say deadlift, right? Referencing the heel is oftentimes one of the big challenges for a lot of people, and you want that, but for a lot of people, the tendency is once it gets heavy, you lean onto the balls of your feet, right? You lean onto the balls of your feet, because then you can do this with your ankle to finagle some more force out of it, right? Is intuitive, but it ain't, it's not mechanically sound. Anyways, so if that's the thing that you're trying to figure out, meaning does this person have the heel? Does this person tend to rely on the heel? You can throw different tasks at it to see if that's something they have internalized, or is that something they simply have to keep on top of their mind? It's like a phone number that you don't actually know, right? Somebody tells you a phone number that's going to save your life. What are you going to do? You like a brand new phone number you never know before. You're going to keep repeating that verbally until you go and dial it, right? So that means you don't know it, because if you did know it, you don't have to think about it. You just show up and you dial, right? Your mom's phone number or whatever. Maybe aging myself now, but anyways. So with movement patterns and different aspects of it, it's exactly the same thing, right? So if deadlift is one thing, deadlift is the thing that you're working on. Think about another pattern that this person is okay with doing. I don't know, a squat or lunge or single leg balancing, single leg hinge, or whatever it is, to see if their own incentives is enough to hold on to the heel, right? Can they initialize holding on to the heel themselves? That's a really useful tool for figuring out, does this person have this pattern, right? And once you figure out, okay, cool, they have it to this degree and you're satisfied, then start disturbing it a little bit, right? So for deadlift, one of the first things I would want to do is lower the weight a little bit, or work with a working weight rather than like training weight, and shift their weight into one leg. Shift, like both their legs are on the ground, right? Shift their weight into one leg. Can they hold on to that and still get up, right? That tells me how resilient is the bilateral pattern and all the little things, because it's the same thing if you do it with weight shifted onto one leg. All the principles, all the underlying principles are exactly the same. You still have to use abs to hold on to your spine. You still have to drive from your legs. You still have to balance through your heels. Do you have all those things? If you do, you're going to be able to do this, right? If that's too hard, well, you go back to regular and figure out, what did you miss? You missed something. Well, otherwise, they would be able to hold on to it, right? You missed something. And it gets interesting when you cannot find anything you may have missed. So then maybe that shift is too big of a jump. So maybe find a less complex or less threatening middle point. So perhaps put different. So if this is a barbell, let's pretend it's a barbell. Put different weights on either side of the barbell. There are no laws or rules that tells you it's going to be bilaterally loaded or symmetrically loaded, right? So perhaps take 5 pounds off of one side. Do it. Oh, everything's okay? Cool. Take another 5 pounds. Just do that until a breaking point, right? And then start working through that, right? What did you miss? What happened? Meaning, they do it and it's like maybe the offset is 20 pounds. Let's just say, for argument's sake, right? 20-pound difference between one side of the barbell and the other side of the barbell. You do it, and they immediately start doing something else, meaning going back to the bad pattern you were talking about, whoever asked the question. Meaning you either tip onto your toes, or you extend your spine, or whatever it is. Then that's an opportunity to have them pay attention to that, meaning you observe it, and be open-ended. I would tell them, I could do it one more time and see if you can notice a difference in this set, right? And just work from there. Again, the key is for them to figure out or to perceive the truth of what they are doing, right? Because they probably think they're doing fine, right? They probably think they're doing fine, and they don't know that, right? They don't know that, right? That's the first step, and then the adjustment is easy. You just got to identify that common ground between the functional pattern, the new higher functional pattern you're trying to build, and the old dysfunctional pattern that they fell back on, right? You need to find that bridge. Once they're aware of it, the solutions are very easy. Yeah, so hope answer that question.
Yeah, that's excellent. So I'm gonna. This next question is very specific. Almost, it's like a case study. We'll say it anyway. We'll see if it works.
Yeah.
So what are some keys to training a woman during pregnancy to offset the anterior displacement center of mass, increase the anterior pelvic tilt, and increase lumbar extension?
Yeah.
So it's very specific. Yeah, so maybe it's not the right time for now. Maybe we'll kind of park it for another time because it's a little bit out of the range of what we just talked about. I mean, there's a lot of things along with that. So not that we're trying to ignore it, we're just trying to see if it's related to everything that we're going to go for.
Yeah, so let me just comment on that reason why we don't think this is appropriate. And, Kento and I are not in cahoots with this. We don't know you're going to answer this or ask this. It's just sort of how we think. In that, like, for something like that, we would need a lot more information about this person, their training history, perhaps injury history, or whatever. We need a lot more than just the fact that she's pregnant. Because without enough information, we're not even sure if we can give you useful information, right? But yeah, let's jump on to the next one then.
So from the prepared questions, that was it. I think it's kind of getting late, and yeah, some people are kind of starting to come out. Never mind, there's a question here. So I'm going to open up the questions and we're going to just take, like, let's say 8 more minutes, 7 or 8 more minutes, because I have to go as well. Yeah. So if anyone has open questions, let me know. I'm going to read this question, Mike, as we are waiting. Yeah. So if anyone else has questions, please let me know. Okay, this is a good question. I like it. So ready? So there's so much talk about fascia release, which we know we don't have the force to do that, right? And getting the fascia to slide and glide together. I hear very little about getting it to help it stabilize better, so this is great. What do you think about all the work to get the fascia gliding versus the fascia stabilizing work? Okay.
I'm not sure what fascia stabilizing work means. My interpretation when I hear that phrase is using fascia to stabilize movement or posture. I hope that's what you meant too. With respect to fascial release, it is it's an interesting thing. I think you can probably get the superficial layers to glide a little bit, but that really isn't the key. That isn't the point, because these tissues are designed to glide and slide, not from external friction, external sources of friction, but from displacement between bones and forces produced by muscles. So, it's I would consider it inappropriate utilization of a pre-existing mechanism designed for something else. It's like using a race car to move your house. But they're both cars, they're both motor vehicles, but different job for the different guy, right? And if you really want to get your fascia conditioned, to get them to be conditioned to move and glide properly, movement is probably your best bet. It was designed to do that, and whatever issue you had initially encountered to land you in this situation was probably a movement dysfunction or psychological stress. Neither of those are going to be optimally addressed by some kind of a passive release. You got to find, how did you end up here? It wasn't because of a lack of a tool, to glide that. That's not how problems come about. You're then just going to the best of my knowledge, you're then just going to create a new vicious cycle. You were already in one. Now you're in a second one. Great. You're going to make somebody a lot of money, but I don't know what benefit you're going to do to yourself. Now, with respect to stabilization, that is an excellent topic. So the fundamental mechanism of it is that tree thing, meaning trees on city sidewalks, erect 4 wooden sticks, mutual tension into it. So it's about opposing forces. Think of rubber bands hooked up to your finger, and somebody pulling on this end, somebody pulling on that end. That finger is going to be very stable. More importantly, if you try to move it in this direction, that rubber band is going to be loaded. That rubber band is going to be loaded. And it forms a self-regulating mechanism, because the more you go this way, the more it's going to be expending your force and energy reserves, because this thing is loaded. So the more you load it, the more powerful it is, right? So eventually, when you get tired or when you're done with it, you're going to come back just as quickly. And the opposite direction is going to regulate how far you're going to go. So you're not going to go too far. You're going to go back to exactly where you need to go. So if we take that analogy and apply it to the spine, it's the same thing. It's the same freaking thing, right? So we've seen earlier that the thoracolumbar fascia, i.e. the obliques, are hooked up to the front, the back of the spine. Well, the obliques are hooked up to the front of the spine as well through the linea alba. Okay? So, because you think of that rectus sheath and that thick band of connective tissue in the middle. I almost see that as a soft spine in the front, because that hooks up your pelvis to your sternum, right? So now you have a loop, right? You have a loop, right? If this is the body, this is the front, this is the back, you have a loop, right? That goes in this direction, and then the obliques along with the thoracolumbar fascia is a horizontal loop. So you have a vertical loop and a horizontal loop to make a really effective system that gives you oppositional support in every conceivable direction. So when you have that, then everything is stabilized perfectly, and whatever perturbations is going to be immediately dispersed across the tensional network if you have everything intact, which is why obliques are so damn important. They're the key to all of this. But yeah, I hope that answered your question. Is a very general level question. So I don't know where to go with respect to specific examples or anything like that. But yeah, Kento, I think we'll probably got time for one more.
One more, yeah, exactly. And I think this is a perfect way to end it, actually. Yeah. So we'll just do one more here. One asked, would you mind sharing a book/resource recommended to understand the fascia system better? And I think that's a great way to finish it today.
It's an excellent way to end today. And there's no way I can just give one. There needs to be a handful. There's no way I can give one. Just 1 second. I hope I can find it in time. Okay. Crap. Okay.
Well, so, it doesn't have to be now, Mike, because I'm going to email everyone after this.
Okay, perfect.
So when it comes to, I know there's like a biointensegrity book out there that I know you might recommend.
Yeah.
So I'll talk to Mike about this afterwards, guys, and I'll send you the resource. Oh, there you go.
Yeah, so there's two. There's a biotensegrity specific book, which is this. You want to make sure you get the right author. There's a handful of books out there that is just simply titled biotensegrity. You want to get this one.
Yeah, for the guy, for the individual that asked that, definitely that's the one.
And there is another fascial function specific book that is absolutely invaluable. Absolutely invaluable. I'll find the name. It's somewhere in my house. I'll find the name and let you guys know. But it has something to do with like there's three important fascia books out there. Two of them are anatomy, fascial anatomy. So stand by for like really gross, freshly dead cadaver pictures, just incredibly accurate, but also just get ready. If you're not used to seeing that kind of stuff, it's it's a shock sometimes. So two of them are like that, very, very accurate anatomical references, amazing books, but you're probably gonna get grossed out. The third one is a lot more about function. It's not nearly as much about anatomy, but it teaches you what does it do, and a crap load of very updated references. But yeah, we'll get that out to you guys whenever.
Yeah, perfect. Yeah, and I have a couple of people that we can't get to the question, but some other day, guys, some other day, because we can go forever if we wanted to.
Yeah.
So Mike, thank you so much for coming. This is probably not going to be the only one if people are wanting this, and we are probably going to offer this a little bit more. So we'll kind of stay tuned.
Yeah.
For us, from Kamiyama PT standpoint, 2 weeks from now, we're going to be back in a webinar. We're going to have an osteopathic doctor coming to visit us, not visit us, like being a guest speaker. And we're going to talk about osteopathic treatments when it comes to trauma. It's going to be talking about the cranium. And so for those that are interested, come on over. It's going to be kind of like headache based. If you have headaches and adult headaches, chronic headaches, these are going to be cool stuff to at least go into. So thank you so much for coming, guys. Kind of watch out for the replay. My computer works. And I'm going to definitely, Mike, you're going to help me with the computer to figure this out. Yes. Anyway, thank you so much for coming. Mike, thank you so much. As always, this was such a treat for me. And have a good time, guys. Have a good one.
Bye, guys.
Thanks for watching this video. If you found that helpful, and if you now are thinking that I wonder what else this person can help me with, please go to our website at www.kamiyamapt.com and find other free contents or apply to our free discovery visits to further see if we can help you. For any further information, please email us at info@kamiyamapt.com. Thank you so much.